Hi guys, welcome to the channel. My name's Jared. Today we're going to be talking wheel alignments for beginners. I'm going to talk briefly about camber, caster and toe, the three main parts of wheel alignments to begin you off to start understanding wheel alignments. Personally me, when I started out with my first Golf and Sylvia I always just thought that getting a wheel alignment was you take your car to a shop and you trust them and they do it. And I was very probably naive at that stage to really understand what they were actually doing. I just thought a wheel alignment was a service and it was generic, but it's very much not that. So a wheel alignment is very specific to every single different car, and even the same person with the same car, they might have a different wheel alignment, or they might prefer a different feeling to someone else. So in basic terms, the wheel alignment is a mechanical adjustment on the suspension through points of linkages where they're attached, and the whole aim or the goal is to improve or optimize the contact of the tire on the ground. So whether it be angled or pointed in, pointed out, all those types of things. And how you adjust it is ultimately going to affect how the car performs and how it feels when you're driving. So just to explain what actually happens when you take your car for a wheel alignment, most people, they drop their car off, and what they do is they put their car on a laser alignment machine. So this is the quickest way, not the cheapest, because these machines can cost $15,000 or more, but they're the quickest way to do a wheel alignment. So I'll insert a picture here of what it looks like, but there's a machine that attaches to the outside of the wheel, and it actually touches on this outer face or lip of the wheel. Because the wheel itself is actually straight. It's manufactured straight by a machine. If you attach anything to the tire, it can be very much affected by how the tire is worn or how it's inflated. So this machine actually reads and measures off the rim of the wheel. So when we're doing our wheel alignments, we're not actually measuring the tire, we're actually measuring the wheel, because that gives us the most accurate measurements. So from there, they've got your car on the alignment machine with the measuring devices attached on each wheel. There's a laser that shoots down onto each of those wheels, and how it reflects the light off in any direction tells them the actual position of the wheel. And in those machines, they pretty much type in the make, model and year of the car, and the manufacturer has specifications that they deem ideal for the vehicle. This specification is by no means the best performance or the best economy or the best feeling. It's just what the manufacturer deems that they feel is probably the overall package for your car. So then they go ahead and they adjust the camber, caster, toe, etc. to those specifications that the manufacturer has suggested. There is absolutely no reason why you can't ask for a different alignment depending on how you feel, but this is then going to stem into your understanding of the alignment and what you actually want to get from the car. Some people, they want to get economy or feeling, and other people want to get performance, but I'm going to assume you're watching this vehicle today because you are after a performance orientated alignment for your vehicle. I'm just going to go through this sheet. When you get your alignment done by an alignment shop, they usually can supply you a printout, which is the settings before and after the wheel alignment. I very much suggest getting this. You can actually check their work, because if they do a really bad alignment, it's going to show up on this piece of paper. And B, if you're trying to work out what alignment works for your car, if you save these, you can compare it to the last one, because sometimes it can be a year or multiple years between alignments or when you get your tires changed. So starting off, as you can see here, we have a before column, which is our measurements before, and an actual column, which is our reading after the measurement. Then over here we've got the rear axle split into camber and toe, and the front split up into camber, caster. We won't talk about SAI or differential angle, and toe. These are the three things we're going to talk about mostly. So first we'll just start off with caster. And as you can see, I've come in and I've had 2 degrees of camber on the left side and 1.3 degrees camber on the right side. After the measurement, we ended up with 1.5 and 1.4, and the difference here, cross, means the difference between the two is 0.06 degrees. Alright, so let's just unpack camber to begin with. So you might be aware of the camber stance, boys. That's usually when the wheel and the tyre is leaned excessively. This can be categorized either in, if it's cambered into the center of the vehicle, that is negative camber. If it's in the middle, this is 0 degrees, so 90 degrees perpendicular to the ground. And if it's leaning out away from the vehicle, that is positive camber. Here we're just looking at the side of my Civic, and as you can see, the bottom edge of the wheel is pointing further out than the inner edge. So that means that the wheel is negatively cambered in. So if we're looking at the tyre from the front of the vehicle, if we lean that into the vehicle, we're adding negative camber, as I mentioned before. So with the excessive negative camber, when you're driving down the road, the actual outside edge of the tyre here is not actually making contact. So that can actually reduce the amount of traction in a straight line motion that you can get. The advantage of running negative camber is that when you actually go into the corner and the suspension compresses, the tyre actually rolls flat. So as you're going around the corner, what happens is you go into this position like this, so the actual tyre becomes flat as you're driving through the corner. Whereas if you are positive, as you go around the corner, it actually adds even more. Or if you were in a neutral position, as you go around the corner, it rolls into that positive camber. So to maximize cornering performance, you have to add a bit of static negative camber so that as you go into the corner, that contact patch becomes the most stable with the ground, because the most surface area we can contact with the ground is going to give us the best performance. The downside to that is that most of your driving is done straight, so what's going to happen is this outside edge of the tyre, because it's not touching the ground, is actually not going to wear as much as the inside edge of the tyre here as it rolls down. So that's going to lead to more premature tyre failure. But for an example here, we had 1.5 to 2 degrees. This is not an excessive amount of negative camber. Some vehicles are only aligned with 0.5 degree of negative camber, and track cars, for example, could be 4 or 5 degrees camber. And if you're drifting, it could be up to 7 or 8 degrees negative camber. And that's all going to depend on the amount of steering angle and load on the suspension. So if negative camber is going to give us more performance in the corners, neutral camber is going to give you the best tyre wear, like I said. So when you're driving in a straight line, you're going to wear the tyre evenly. Only in very limited situations would you actually run positive camber. So positive camber is generally run by drag setups or people with solid rear ends in their vehicle, because what happens is when the car squats in an accelerating state, so you'll see when the drag cars take off, the rear actually squats down. At this point, when the suspension actually squats, negative camber is gained in the suspension alignment. So you go from a positive to a neutral, or maybe even to a negative position. So this way that when the car's accelerating, they get the most even contact patch on the tyre, like I was saying. Moving on, next we're going to touch on toe. So this one's measured, could be measured in millimeters, inches, and sometimes degrees. And in this case, in the rear, there's actually 6.5 mil of toe in on one side and 2.2 mil of toe out on the other. So that's a really terrible wheel alignment that I've come in with. And after, we've ended up with 2.6 mil in and 2.8 mil in, and total toe, which is 5.3, which is a sum of these two together. So toe is easier to show off from behind the wheel. So as you can imagine, like my Civic over here, if the wheel is pointing straight, the tire is going to roll straight as well. If the wheel is pointing in, that is called toe in, because it's pointing into the center line of the vehicle. If the tire wheel is pointing out, that's called toe out. So in a neutral position, this is going to give you the best amount of tire wear, because it's going to create the least amount of friction on the road. With a toe in on the right and a toe in on the left, sort of exaggerated in this, the two wheels are actually going to be pushing together, and that's going to create some amount of scrubbing on the inside of the tire. In this configuration of being pointed in, this is going to create the most amount of stability in the vehicle, and it's going to keep the car straight. If you were to toe that tire out and this one out, what's going to happen is when you're driving straight, depending on how the suspension is, the steering can actually pull left or right. So this is a more unstable type of suspension of toe alignment. Performance orientated cars and track cars tend to run toe out, and the advantage of that is that when you turn into the corner, the inside wheel is actually already pointed right and the left wheel is already pointed left. So this can actually give you a quicker steering feel, but it gives you more unstable steering feel. So if you took your car to the alignment shop, they're going to give you toe in, which makes the car stable, and it also makes the car drive straight. But if you want to make it if you want to get the most wear out of your tire, a straighter position or neutral zero toe position is the best. And if you're looking for a really performance orientated alignment, you're going to go for something with toe out. I'd recommend for most street cars that you're driving every day, 1, 2 or 3 mil of toe in. If you want like a sort of fun weekend car, you could go for 0 toe. And if you have a track car, I would probably go 1 to 2 mil toe out. If you were to have 1 millimeter of toe in, that just refers to if you had the center line of the tire like here, and you pointed it in 1 mil off that center axis, then that would be 1 mil of toe in. Some people measure it in degrees, so if this is 90 degrees or 180 degrees, as you turn it in, you're adding degrees of toe in. So if you had this wheel towed in 1 degree and you had the other wheel towed in 1 degree, you have a total of 1 plus 1, 2 mil of toe in. One thing to note as well is that you have toe adjustment on the front and the rear of the vehicle. So in the rear, I always recommend that you run toe in, because like I said, the toe in is going to make the car go straight, and the rear of the car is going to be pushing or dragging the vehicle, depending on if you're front wheel drive or rear wheel drive. And if you have a lot of toe out in the rear, it can actually cause oversteer. So I would recommend always to toe in the rear and play with your toe neutral or toe out in the front for your steering feel as you go into the corner. So again, in this case, with 2.5mm toe in, it's actually not a lot in the rear, but that is to create stability. In the front, as we talked about camber already up here, I only had 1 degree of camber in the front, and I left with 1 degree in the front as well. Then for caster, we had 8.22 degrees and 8.1 degrees, and I left with 8.2 and 8.1 degrees. So now let's touch on caster and what that means. So for example here, I have a spindle, the stub axle, knuckle, whatever you want to call it from a Civic, and this is double wishbone suspension, where it has a lower control arm and an upper control arm. So you can imagine in the vehicle that it is positioned like this, and if you're looking from the side where the wheel is mounted, it'll be vertical like this. So caster is either the top ball joint behind the bottom one or in front of the bottom ball joint. So most cars are positioned back like this. So just like a caster wheel on a shopping trolley, this is going to help center the wheel, and when you're going around the corner and you let go of the wheel, that is going to go back into a centered position. So with this position back, it's in a positive caster position, and in the front, negative. So you're pretty much always going to have a positive caster position, and the amount of caster is going to be determined on probably the adjustment on your vehicle or what you want to do. So drift cars, for example, they're gonna have a lot more positive caster because they want that self-centering steering feeling. So as you might see, as they drift around the corner and they let the wheel go, it spins back. That is the caster doing the centering. Caster adjustment is generally either to the front of the vehicle or to the rear of the vehicle, and that's pulling or pushing the bottom of the control arm. Some other upper control arms have camber as well as caster, so again you can push back or pull forward that caster adjustment. So what you'll see is as you add positive caster, that wheel will actually move closer to the front fender, and your limitation may be that the wheel contacts on the fender. So I'm just going to wrap up that explanation of what camber, caster and toe is for now, because I think that's as limited as you'll need to know for a beginner. The last thing I need to mention is that even if you ask for 4 degrees of negative camber or 10 degrees of caster or 5mm of toe out, the person wheel aligning your car is not necessarily going to be able to achieve that, and there is very fine limitations on the factory adjustment, because usually from factory they come with like an eccentric bolt, and you might only have 1 to 2 degrees either way of adjustment, and they are designed, or that suspension is designed to be aligned within those factory specifications like I mentioned earlier. If you want to go outside of the factory specifications further than you can achieve, you're going to need to look at things like adjustable arms. So these are going to have much larger adjustments rather than the 1 or 2mm from factory, but it's going to make it then even more difficult to do your wheel alignment, and it's going to be more expensive to buy those arms. But if you want to achieve that, then you're going to need to go into that direction. So that wraps up this video. I hope this was a good introduction for you on wheel alignments, why they're done, how they're done, and maybe spark some thoughts on the type of wheel alignment you want to have in your vehicle. I have another video on my channel where I talk about how to do wheel alignments at home, and I strongly suggest you watch that and also play around with the settings on your wheel alignment too. And I would say beginning that you if you're starting out, that I would trust the judgment of the people at the wheel alignment store, because they're going to know more than you. And as you experiment with different settings and you see how it feels and how it relates to your vehicle, because like I said, every vehicle is different on how they feel, that you go from there and you build up a bit of a repertoire of the feeling and what you're looking for in the vehicle. If this video was useful, please give it a thumbs up, like, comment, share, subscribe, and I'll see you in the next video. Thank you.